Hello, welcome to Jiva.ai's Agentic AI platform. This is a demonstrator to show how easy it is to build a classification model to predict heart disease. So I've gone over to Kaggle and I've managed to find a heart failure prediction dataset with a usability of 10. And what we have here is 918 patients from these hospitals. And with that, we've got the following data. So their age, sex, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, resting ECG, maximum heart rate, exercise angina, old peak, and ST slope from the ECG. And finally, did that patient have heart disease or not? So what we'll do now is we'll jump over to Jiva. We'll see how easy it is to build an AI model to predict whether the patient's got heart disease or not. So we'll create a new workflow. And our platform works via nodes. And if you imagine these nodes are the backbone of our generalized agentic AI platform. So the nodes are segmented into input and output. So where is the data? Is it online? Is it somebody's software? Is it on a server? Is it a remote file? And again, we're agnostic to any sort of AI data type. So it doesn't matter if it's imaging or tabular data or documents. We ingest all of that. And then you've got a whole bunch of processing and engineering nodes. So we might need to convert that data to make it useful to machine learning, or we might need to engineer the data, such as segment the images or rescale the images or change the column type. So we can do all of that over here. Scaling and selection. So if we need to do any sort of feature selection, we've got all of those type of nodes here. And then you've got your AIs. So we've got all types of machine learning, whether it's classification, regression, NLP, large language models, intelligent document processing, image analysis. So these are all of those type of nodes over here. So without further ado, I'm going to jump in and I'm going to bring up the data. So the first thing is, you can see I've been building quite a lot of models recently. There's our data. Just going to have a look at it. There you go. So I'm just going to bring that data set in. And the next thing I'm going to do is I'm going to define what I'm looking for. So define the inputs and targets. So these are my feature columns. And what I'm trying to predict is heart disease. Next, I'm going to encode everything that was non-numerical. So things like sex, chest pain type, everything that basically that was non-numerical. Resting ECG, ST slope, exercise angina or not, and heart disease or not. It's always good practice just to shuffle up the data set. Next, I'm going to split the data. So I'm going to use 80% to build my algorithm, and I'm going to keep 20% back and blind to test my algorithm. I'm going to normalize any columns that had large variations into a 0 to 1 scale. And that's, again, just good data science practice. So things like age, resting blood pressure, cholesterol, and maximum heart rate. And then I'm going to bring all of this into a neural network. I'm going to make it 6 layers deep. I'm going to train it 1,000 times. And then all I do is I just connect the nodes. and we just press run. And as you can see, it took less than a minute. And in that minute, we managed to build an algorithm with a 73% accuracy. So we built an algorithm with a 73% accuracy and under a minute. Now the whole agentic part means that we can take the output of this and put it into another pipeline, and then that could automatically text message the patients or the doctors to bring that patient in and actually automatically book that patient into clinic. So that's the point of each pipeline becoming an AI agent. I hope that makes sense. Thank you for watching.